class. So now we want to scaffold out our albums controller. So we'll see if we pick new controller. Actually, no, sorry, we don't want this. That's not the option we want. We're going to add a new item. And then under core, we're going to pick Web API controller class, which we will call albums controller, same way we did in our MVC app. So add new item, Web API controller class, call it albums controller. So it will scaffold out our 5 methods, 2 gets, a post, a put, and a delete. So if we build, we should be able to hit the URL API/albums, and it's right now going to give us exactly the same as kind of our dummy values controller. So if I go to API/albums, it'll give me value 1 and value 2. If I put in some kind of number here, just prints out the word value back as a string. So we need to make a reference to our model so we can connect to the database and reference our album model. So we can do create, read, update, delete based on that album. So we're going to reference our music store model class. Doesn't know what this is. So again, it's asking us to provide a missing reference. So we just need to reference our model's namespace. So I add the reference to my models. Music store model turns blue, it's recognized. So now we're going to write a constructor that uses dependency injection. When our controller gets instantiated, it should also instantiate or have access to our database class. So rather than instantiating the database class here, I'm going to do it through the constructor. We're not going to write unit tests, but at least we're set up to write unit tests if we choose. We could have an overloaded constructor where we pass in a mock object instead. So now let's change our first get method. Right now, this just returns an array, a list of strings. What kind of object should we be returning instead of strings when the user goes to albums or API/albums? What should we show them? Yeah, so we want to return an IEnumerable. It's actually album. It's not actually IEnumerable we're going to return. Because, so in our API, actually, sorry, we can leave it this way, but rather than returning a string, we can just use a link query, right? db.albums.order by. Where we run a query, order them, and return it as a list. Okay. So we have one issue here. Doesn't know what albums is. So what it's saying is our music store model doesn't have an albums property. But it suggests a fix here. Generate a property in the music store model called albums. So I'm going to choose that option. Okay, so we're just going to modify this. Instead of an object, it's going to be of type dbSet. And we'll take out internal. So we're setting a public database set of type album called albums. This code is actually in our scaffolded code from the MVC app. If we go and look at our DB context class, our music store model online on GitHub, right? Here's our music store model. When we used the Entity Framework Wizard, it generated this stuff. All the tables we included in the model are listed here as DB sets. Because we built this manually, we didn't have that line. So now it knows what albums are, right? It's a property of DB set of type album found in our database model. So now if we build, we should be able to browse to API/albums, and hopefully we get a list of all the albums in the music store. So rather than fake data, we're getting real data. Let's go back here, and I'll try albums with no ID. Okay, well, we're close. We got an error. In .NET Core, they've gotten rid of the lovely yellow error screen of death. It's now a white error screen of death. Pretty simple and clear problem, right? Our model is called album. In the database, it doesn't find an object called albums. There's a simple fix for this. So the way Entity Framework is designed, if we call our model album, Entity Framework automatically looks for a table called albums, plural, with an S. But the table in our database is actually called album singular. There's no S if you look in the SQL Server. But there's a really simple fix for this. Up here above our class, we have to specify the actual name of the table, which is album singular. Now it's not liking this. Another data annotation reference will fix it. This time, the subclass data annotations.schema. Now, if we save, build, refresh, we should get all 249 albums as a JSON object spit out in our browser. So there's our music store, sorted alphabetically by title. Again, if you don't have that little plugin, the data looks like this. So you can see why we installed that little REST client add-on in Firefox or Chrome. So rather than this, we get formatted JSON. So now this API is public. So anybody can build any kind of application in any language. As long as it can consume JSON, it can go and take this album data. Could be iTunes, could be a mobile app, could be Spotify, could be an application in a music studio where they want to access that list. Now, we wrote this one as a synchronous method. It just runs the same way as it did in our MVC app. All of the other methods, we don't need to write them asynchronously, but we may as well. We're going to try it. We have that feature. Now, we're not really doing other things instead, but I want to show you the syntax and how the asynchronous methods are a little different. So I'm going to also change the comment. It's not API values, it's API/albums. Right? Probably a good idea when we're creating an API with each method to include the root or the URL where that method gets invoked. So I've changed all my comments, all the paths. So there's our get. It's kind of analogous to our index method in our MVC. There's no parameters, so just get all of the records in that one table. But we also have the ability to get a single record based on the ID, just like our details method in our old controller. So rather than returning a string here, we're going to do a few things here. Rather than a string, we're going to return what's called a task. And the task type that comes with it is an iAction result. So iAction result is an interface. And we're going to want this to be an asynchronous method. So we can add the attribute async into the method header. So that means we could call this method, it will run asynchronously. We could then have other methods execute, and then the code will come back here when it's done. We're not adding other methods, but I want to show you how we would do it using asynchronous code. So we're not returning a value. So the first thing is find selected album. So we'll just write a query. Now, rather than calling first or default, we want to use an asynchronous method. So we'll call first or default async. So run this method, but in a non-blocking way. And again, it doesn't understand this method because this method is part of Entity Framework Core. If we don't reference Entity Framework Core, we can't run asynchronous methods on the database. So I'll just add my reference. And instead of fixing it, now the whole thing's red. There's two things we have to do when we call a function asynchronously, and we've done one of them. The first one is we include async as part of the function name. The second thing is we need to prefix it with the await keyword. Now our error goes away. So both of these things are required in order for the compiler to understand this method should be run in a non-blocking way. Prefix it with the command with await and use the async version of the method. So now we'll check. If nothing comes back, we'll return not found. When we call not found, you can see the status code, the HTTP status code. When I mouse over not found and see the tooltip, right? What status code represents not found in HTTP? If you browse to a page that doesn't exist, what error are you going to get? 404, right? So by returning not found, that enumerator will send a 404 response to the browser. Otherwise, we return an OK response, 200, an HTTP 200, and we pass in the album. Remember, we're not loading a view here. We're just sending the data back to the browser with just sending a view back to the browser with status code. Sorry, the JSON, the object back is JSON and an HTTP status code. There's no view here. So now we should be able to run this. We just go to API/album/, and we can try it both with an ID, with a valid ID as well as with an invalid ID. We don't need to check for no ID. If we have no ID passed, what happens? Look at the URLs of our methods. So what happens if no ID is passed to API/albums? Nope, it's not an error. Yeah, it runs this method. It runs this version instead because they're both using get at the same endpoint. So we don't need to check for empty. If they don't give us an ID, we give them everything. And if they give us an ID, then we've got two possibilities: not found or okay. Right? So here there's nothing, so it will give us all. If I put in a valid ID, I now just get that one matching object. If I put in an ID that doesn't exist, we get nothing. But if I actually go to the console, actually, where do I want to go? Web console. Here. So in my network, we can see that I get a 404 response returned if it's an ID that doesn't exist. The method was get, the status was 404. When I put in something valid, we get a 200 and OK response along with our object. So if another application is consuming this API and it's calling get, it can inspect that HTTP status code to know whether it got an object back or it got an error. So if they got a 404 back, their application needs to handle it and like show a message to the user, not found. We can't control what their UI does. We just have to send back the right information. That's success or failure. So through the browser, we can basically run the GET request through the browser. We just need to put in the URL, and we're going to get back either a JSON object or some kind of error. For the other methods, this is where we're going to use that Postman tool, because if we just type in a URL in the browser, it automatically runs a GET. These other methods, this one we need to do a post, this one we need to put, this one we need to do a delete. So, I mean, we could simulate it by building an HTML form and posting to those URLs. It's not very efficient. So if you installed the Chrome client, or better yet, if you installed Postman, let's open it up, because Postman allows us to make any type of HTTP request and send it to any URL and see what we get back. So if I just go in here, you open up Postman and click on, I'll just close this window. So here's the main window. We pick an HTTP method, we enter a URL, and we also have the option, well, not with GET, but if I pick post, I have the option to supply a body to that method. So I can do post for trying to add, I can do put for trying to update, and I can do delete. So we can actually execute the request from here and inspect the responses. So let's write our post method in our API, and then we'll use Postman to test it and see if we can actually add a new album through Postman. So the header is going to be similar. Again, we're going to write this in an asynchronous way. So our post method will be asynchronous. And again, it will return a iAction result. But here the body is a string. We don't want the body as a string. We want to pass in an object, an album object. And our code here is going to be similar to the controller code we scaffolded in our web application. We go back here, look at our controller. So here was our HTTP post for creating. We passed in an album. We checked if it was valid. And if it was, we just saved. So we're going to do similar thing. So again, we'll check the model state. And if not, we'll return the HTTP status code bad request. The request that came in, we didn't like. So this will give a 400 bad request response back. Otherwise, we add the new album. And asynchronously, so we'll call await db dot, and notice now instead of just save changes, we also have a save changes asynchronous version. Asynchronously save all changes. So let's pick that one. Now we don't want to redirect because there is no UI, right? It's up to the client, the consuming client. We're just adding, we want to just send them back to create the new object, because the new object is now going to include an album ID from our database. So we want to send that object back to them. So we're going to return a created at action. So it was created at, the action name here would be post. And we'll give them the new album ID. ID equals, album ID. So we'll pass them the new object and we'll include the ID. So I think this will return, a 201 response, meaning new record created. So in the browser, if we run this, we should get a 201 response back if we pass in a valid album and it saves. If it doesn't, we're going to get a 400 bad request error. So let's build, and we'll use Postman to try this out. So in Postman, make sure we set the method type to post. The URL is your localhost. Actually, mine is not. Mine's on a different port, so I better grab it. So grab your root API URL. So the way that APIs typically work, they don't typically have different URLs. Notice everything runs at the exact same URL, API/albums. It just knows what to do based on the HTTP method we pass in. When we call get, it runs a query. If we do a post, it runs a create. So once you've got this, click on body, and then under the type, pick JSON. Application JSON. So we're going to pass in an object. I mean, you can do it this way. It's got this option for form data, where you could just put in the names of the fields and the values. We'll actually create a JSON object, because that's what we're likely to get from another application, is they'll send us JSON data. Probably not a form post. So I'm going to pick for body. You pick raw, an application JSON. So we'll create a little JSON array here. But let's put in a title. And let's put in a price. apply an album ID, SQL Server will generate that if this works. So now to try this, I'll just send my response and we'll see whether we get back a 400 bad request or whether we get back a 201 created successfully. And that, if that happens down here in the response, we should get the full album object with the brand new album ID, if it works. So our response is going to show up down at the bottom. So I'm going to send this. And it actually gives us back a full HTTP response. We didn't get a 400, we actually got a 500 internal server error. It's a full HTML page, but if we scroll down, we're going to see what happened. Cannot insert null value into genre ID. So genre ID can't be null. And our artist ID also can't be null. We didn't include those fields in our model. So to fix this, we're going to need to go back to our album model, add two integer properties, genre ID and album ID. And then we'll need to include those values in our request body. We can't create a record without them because the database doesn't allow them to be null. So in our album model, we'll just add two more int properties. So we need genre ID and artist ID. So add those, and obviously you need to rebuild your code. And then through Postman, bring it down a bit here. I'm going to add a genre ID of 1 and an artist ID of 1. So that's genre rock and artist ID is AC/DC. So I'll add two more parameters. Your JSON is case sensitive. Okay, so it's got to match, the field names have to exactly match the property names. So we've added those properties and rebuilt on a rebuild, or just a build. Now I'm going to try my request again. Hopefully now we're going to get a 201 created response. And we will get a JSON object down here that includes a new album ID. So there we go. 201 created. And we now have a new album ID of 672. So there's a couple ways we could check this. I could go back to the browser and now go to album/672. Right? If I change my request type to get, now put in the new ID and run my request, we now get a successful 200 response with that album. So we know our create worked successfully. I can go back to Chrome and try it here. So new album comes back and whoever sent it now also has access to the ID. So they know if they need to update or delete, they now have our ID so they can update that record. Because we're sending it back when they created it to them. And you see here we get 200 response. Yeah. So we just need to do update and delete. And we'll have an API that does full CRUD on this. We're not going to get into authentication. I'll talk a little bit about it just for a minute at the end because someone asked about it yesterday, which is a valid question. We're making this public. What if we don't want it public? We want other users to use it, but we want to control access. Who can call our API, right? It may only be for certain authenticated users. So our put method, it's going to be pretty similar. So again, for put, it's going to be asynchronous. Return once again a task. A by action result. And our body, rather than being a string, again, our body is an album object. It's not a string. We want an object of the right type. Again, we're going to check for if we don't get an album object, we're going to send back bad request. Otherwise, rather than adding, we're just going to mark the state as modified. So this is the same as the scaffolded code in our web app when we're doing update. And then we'll do an asynchronous db.save. So just mark it as modified, save the new object, modified object. Ah, whoops, we're missing something. Oh, sorry. No, we're not missing anything. My bad. And now we'll return, instead of created at, there's an accepted at action that returns a 202. An update to the status, basically, of this. Sorry, we've accepted the changes to this. So our action is put. Again, we'll just pass the ID back. So our response will include the whole updated object. So now we should be able to, I want to take that new album we created. Let's try and change the price. It's almost the exact same method as create, except our return is different and we're marking it as modified rather than adding a new album. We can go back to Postman. Change our method to put. I'll leave my new ID here because I want to update the album I just created. And I'm going to go back to the body. Fortunately, it keeps the body for us. So we just want to change the price. So I want to put this album on sale. I'm going to drop the price by $1. Now, somebody asked this question yesterday. Before I run this, I'm going to ask you what you think will happen. We get two options. One option is here, we still pass in the full object, and it updates all the fields, even though we've only changed one thing. The other option is I could take out everything except this. Right? I'm still has the right ID, but I'm only passing in the value or values I want to update. What will happen if I take out everything except the blue line? Will it leave the title, genre, and artist as they are, or will it try to null them out if I don't pass in those properties? You think it'll leave them? Any other predictions? Well, let's try it. I'll cut that. I'll take everything out here, except the price. It still knows what album I want, and it knows what value I'm trying to set. And I'm going to run put. Let's try it. So we got our error. So why do you suppose this failed? Think about the inputs of our method. What's the method expecting? An album object. So it's got to have all of the properties of an album. So even though we're only changing one of the 4 values, this code will actually, technically, will update all 4, even though 3 of them, the new value is the same as the old value. Now you might say, well, it's not very efficient to do that. Why don't we just update the stuff that got changed? Well, we only have 4 properties here. If we had like 20 properties, trying to figure out, in order to only update the new ones, we'd have to compare every old value to every new value, which is kind of a waste of time and tedious. Very rarely do we need to do that. I'm just going to put this back. I'll put my method back. Here's my, so I'll put back my entire object, my price I want to now update from 11 to 10. So I'll run put again. Okay. Obviously, something's still wrong.
It'd be easier to load if you did it for anyone then.
I could grab it and throw it in a browser. Okay, database expected. It's concurrency. Database. Well, let me run get first of all. See if my album's still there. Ah, I know the problem. I never passed the album ID as part of the object. So I need to include that in my request JSON. So let me go back to my body, which is disabled for get because you can't send in a request body. Oops. It's not enough that it's in the URL. It still needs the ID as part of the object. There we go. So there's our response. 202 accepted, and our object now has the new price. On here again, right? We've done the update. We're at 1099 now. So now we just have to do a delete. So for delete, we only need an ID. Again, we'll check the model state. In this case, we'll just, oh, actually we should, sorry, all of these bad requests, we should be passing in what the state of the model is. That's more descriptive. I didn't mean to pass in album. So if we're sending a bad request, we'll send a description of the current state of the object. So now we need to go and fetch this album with the ID, and then we can remove it. So if we have no album matching this ID, we'll return a 404. Otherwise, we just remove it. And then we'll asynchronously save. Now there's no deleted at action. Hang on. HTTP delete status. Let's see what HTTP code we should be returning. For a delete, 200 or 204. So we could well, for the moment, we'll just return an OK. So now we should be able to run a delete at the ID. We don't need any request body. Just takes the ID, the database looks up the album. If it finds it, it removes it. So I'll go back to Postman. I'll change my method to delete. And send that request. So it gave me back an OK. It showed us the object that was deleted. So the question now, if we run a get, whether that album's still there. No, we get a not found, so the delete is working. So there's our whole .NET Core API. So most of the work, probably more than half the work, was actually just doing the setup. And we used asynchronous methods. We didn't have to. We just wanted to play around with them. Now, I did want to take a minute to talk about two things related to this. So one is authentication, right? If we don't control, we're not building any user interface, how can we authenticate if we want to control access? Like we're going to give, let's say, you know, maybe these methods are public. Anybody can look at the albums, but maybe we want post, put, and delete to only be available to the music studios, right? We've got 30 music studios as clients. They provide us with products. We don't want to let anybody just put data in our store. So one way we can do it is as parameters to these methods, to post, put, and delete, we could add an ID and secret parameter. So when they make those calls, they have to include a credential. And usually in the APIs, like we did with our social logins, right? We have an ID and secret for each client. So that might look something like, so here's a call. This is Visual Basic code, but so I had a base URL. So I had to get an access token for each client. And then we stored it in the database. So I would pass in my client ID and secret as part of the URL parameters to the method. That was one way of generating access. The other way, so here's the documentation of this API, is every other call I had to make, I had to provide. So to get a token, you had to do a post and provide your ID and secret, and it returned an access token, which you have to store in the database. And then every other call you make, you have to include the access token. So something like here. So in get, I would include the access token. Another probably more secure way of doing it, which we've got in here, is so here's a post method. So creating a new patient. The documentation says, here's what you need, and you get back a patient object. So much like our post method, we pass in fields and get back a new album. So we would have to attach the token onto it. So here's how I would do it. I set up my request, but then I would have to create, where is it? A header for my request. The URL I was going to send to, and then I created a header with a JSON object. The key name was authorization, and the value was bearer, and then my token. And then I would add this object to my request header. So rather than that being part of the actual body, it was part of the header. So on the API's developer end, before he would start parsing the post data, they would check the header whether I had a valid access token, and it matched my account in their database. So that's typically how we will authenticate. So if we're writing code to consume, to use someone else's API, we're typically going to get a document like this. It describes all the URLs and what type of HTTP method we need to use. And then it explains what parameters we pass in and what kind of response we get out. If we're going to use someone else's API, it's up to us to read the documents, figure out how to work with it. And usually they provide a testing environment so we can play with it outside of production. If we're building the API, who's writing this documentation? To tell other developers how to use the API we're building. Who does this? We do, right? It's your code. If we're writing these methods that other people need to know how to use, we've got to document. Okay, here's what you have. Here's the URL. Here's the method. Here are the parameters, the input parameters, and here's the response type and status code that you're going to get back, potentially get back. And you've got to publish that document, and you got to keep it up to date. Many times, if these APIs are public, the documentation just lives in the README file on GitHub, right? So anybody can go to your repo, they can see your source code. So this API I was looking at, it's actually on GitHub. I think he actually included it. Yeah, so he didn't include the docs here, but his API is public. So one of the cool things is, with APIs, as long as they talk JSON, we don't care. The two applications can be written on different platforms, right? My application's a .NET web application using Visual Basic. It's old. He's got his files have .rb extensions. Anybody know what kind of files those are? Yeah, they're Ruby files. But because we can exchange JSON, it doesn't matter. He can write his API in Ruby. As long as he exposes those endpoints and I follow the documents and send in the right JSON, I can send data or read data in and out of his API. So JSON's kind of the common language that we're exchanging data in. So more and more, particularly when you're working in enterprise level applications, our applications are not standalone. They integrate, they talk, our clients, they do business with other institutions, and they need to exchange data. So this is how we do it, with JSON-based APIs. So I guarantee you, within 5 years, for a lot of you in here, I bet you this will be a big chunk of your workload. Rather than writing all your own code, you're either writing APIs so other applications can integrate with your organization software, or the other way around, or both. You're consuming. I'll show you one last graphic and then I'll let you get out of here. just to show you an enterprise level kind of solution and what it looks like. Here. So this was a project run by a friend of mine for Canada Pacific Rail. So he was hired years ago to oversee the whole project. They wanted him so bad. He lives in Toronto. They flew him out to Calgary every Sunday night. They flew him back home to Toronto every Friday night to visit his family for like 6 months. When we talk about API development, these are all the different applications that Canada Pacific Rail owned that had to talk to each other. Right? So there's all kinds of different servers, an Oracle database, scaling software, logging, mocking, server monitors, web servers, all kinds of stuff. So each one of these are different applications. Many of them are third party, so they're bought directly, like WebSphere. You just buy that from IBM. Some of them were custom built in-house, and his job was to integrate this entire thing so that customers could book shipping trains online. But these were all the pieces that had to integrate. So every one of these, where you see an API, there's an API here to let people in. There's APIs here. Some of these APIs are two-way, going back and forth. Level, we have all these different components put together. So API development management and updating is a huge job. And as we get more and more integrated, developers are spending more and more of our time doing this. So I know we did consume the Google, Facebook, Twitter, right? You know how it works. Create the keys, put them in your app, call the methods. So we've done it from a consumer end. Now we've done it from a production end. We've created an API. It's public. Someone else could use this to talk to us in whatever way we want. If we only want to let them read our data, well, we just don't include post, put, and delete methods in our API. We only let them run get. Control over how this works. Somebody asked me yesterday about Spotify, right? You want to build an application that consumes Spotify data? Cool. Go to Spotify, go to the API, docs, they're all here, right? Here's your endpoint reference. There's all the URLs, all the HTTP methods. They all require OAuth, right? They're not public. So if I want to go and get all the albums for a selected artist, I pass in the ID, right? I provide an OAuth token. Here's my return type. Album, market, HTTP response 200, even with an example. Look familiar? Right? It's what we just did. So if we're going to build the API, we're creating this kind of documentation. You're going to do more of this probably if you guys are working with Node, because Node is cool because it's all, your whole code is JavaScript. Even your database is, your data in the database, it's already JSON. So if we want to expose JSON or take JSON in to our database, it's easy. So this is kind of where we're going with this and how this kind of gets translated into a real life scenario. So probably a lot of you are going to spend a lot more time doing this, particularly if you're in web. All right.